August 28, 1944. Near Saint-Lô, France, Patton's spearheads had covered nearly 100 miles in 5 days, then stopped. Not from enemy fire, but from empty tanks. Third Army's morning return listed 0 operational fuel reserve forward of Saint-Lô. Railheads were wrecked, Cherbourg lay far behind the front, no forward depots existed. Yet, across the Channel, US stocks measured in the millions of gallons. The deficit was not supply, but delivery rate. That afternoon, service forces issued a priority order: dedicate marked road corridors, one-way traffic, military police control, and continuous truck flow from port to army day and night. The Germans expected the American tempo to collapse with its fuel columns. They misjudged the scale of standardized trucks, spares, and drivers available to the US Army. Within days, the Red Ball Express began running at industrial cadence. The front started moving again not because tactics changed, but because logistics became a weapon. That metric gallons per hour delivered would decide the campaign. The crisis that forced creation of the Red Ball Express emerged not from tactical defeat, but from strategic success beyond planning parameters. Operation Cobra's breakout from Normandy on July 25, 1944, shattered German defensive lines so completely that Allied advance rates exceeded every logistical assumption made during invasion planning. On folding tables inside First Army headquarters, staff officers marked fuel consumption against daily march tables while watching the Falaise pocket narrow on situation maps. The arithmetic appeared simple but devastating. An armoured division advancing at operational tempo consumed between 200,000 and 300,000 litres of gasoline daily. Third Army's 4 armoured divisions alone required over 1 million litres per day when moving at Patton's preferred pace. Pre-invasion planning had assumed methodical advance, with rail-fed depots established every 50 to 70 miles behind the front. The transportation plan, the systematic Allied air campaign that destroyed French rail infrastructure throughout spring 1944, had succeeded so thoroughly that those same demolished bridges and marshalling yards now prevented supply trains from reaching forward areas. German collapse created maneuver space far beyond planned supply radii, precisely because the infrastructure necessary to support that maneuver no longer existed. Lieutenant General George S. Patton commanded Third Army with aggressive instincts that viewed logistics as someone else's problem to solve. Major General John C. H. Lee, commanding Communications Zone, faced the impossible task of supplying armies advancing faster than transport capacity could sustain. The tension between operational commanders demanding fuel and supply officers calculating feasible delivery rates dominated every planning conference during August. First Army quartermaster returns documented the crisis in stark numerical terms. Forward stocks were measured in hours, not days. Tank battalions reported fuel levels below 50%. Artillery units conserved ammunition for defensive fires because resupply convoys could not reach them. Medical companies rationed plasma and bandages. The spectacular tactical success that liberated most of France by late August risked stalling completely because mobility depended on petroleum products that sat uselessly in distant ports. The cause-effect relationship appeared brutally clear. Operational success had outpaced supply doctrine. The US Army had planned for steady advance against prepared German defences, with time to establish forward depots and repair rail lines as forces moved east. Instead, German armies had collapsed, opening vast maneuver space that demanded immediate exploitation before enemy forces could reorganize. Mobility risked stalling at the Seine not from enemy action but from empty fuel tanks. By mid-August, staff officers calculating supply rates against advance schedules reached an uncomfortable conclusion. The decisive constraint was no longer enemy resistance, it was miles per gallon multiplied by miles to the port. Patton's tanks could defeat any German force they encountered, provided they could reach the battlefield. That "provided" had become the campaign's critical question. The solution emerged not from tactical innovation, but from industrial reality. The United States Army possessed the largest motorized transport fleet in history. built through 3 years of systematic production and standardization. That fleet represented not merely vehicle quantity but interchangeable, maintainable, scalable logistics capacity that could be redirected from general hauling to priority delivery, if properly organized. American military vehicle production during the war years established standards that remain remarkable 8 decades later. The GMC CCKW 2.5-ton 6x6 truck, universally known as the Deuce and a Half, rolled off production lines at extraordinary rates throughout 1942 and 1943. Total CCKW production exceeded 500,000 units by war's end, supplemented by hundreds of thousands of Dodge 3/4-ton trucks, Dodge 6x6 variants, and 10-ton tractor-trailers for bulk petroleum transport. At inspection lines in Detroit and dozens of other production centers, workers stamped acceptance plates on trucks that shared engines, tires, brake systems, electrical components, and countless other parts. This standardization represented deliberate planning rather than manufacturing convenience. The War Department's Ordnance and Quartermaster Corps had recognized early that global logistics required interchangeable components that could be stocked at forward depots without maintaining separate inventories for dozens of different vehicle types. The contrast with German motor transport proved decisive. Wehrmacht logistics relied on hundreds of different truck models, civilian vehicles requisitioned from occupied territories, captured Allied equipment, and limited production runs from German manufacturers. A tire that fit a French Citroën could not be mounted on a Belgian Minerva or a German Opel. Brake components from one manufacturer proved useless for vehicles built by competitors. Every maintenance depot required vast inventories of non-interchangeable parts or accepted that broken vehicles would be cannibalized to keep others running. American motor transport in the European theater of operations counted hundreds of thousands of vehicles with depot-level spares forward. A CCKW truck breaking down in France could receive a replacement engine, transmission, or axle from stocks that fit every other CCKW in theater. Tire sizes were standardized across multiple vehicle types. Tubes, batteries, spark plugs, and countless other consumables required minimal inventory variation. This standardization meant maintenance could occur at scale rather than through individual vehicle attention. Transportation Corps planners had recognized another critical factor. Convoy control required coordination rather than communication. Individual trucks lacked radios. Installing and maintaining such equipment in tens of thousands of vehicles exceeded both technical capacity and operational necessity. Instead, control occurred through military police checkpoints, designated routes, and enforced march discipline. Drivers followed prescribed routes at specified speeds, stopping only at designated refuel and rest points. This system worked because the roads themselves became the communication network. The truck fleet built for scale now enabled sustained road supply precisely when rail infrastructure remained down. German forces had destroyed rail bridges systematically during their retreat. Allied air attacks had demolished marshalling yards and destroyed rolling stock. Repairing this damage would require months of engineering work. But the roads, though damaged by combat, remained fundamentally intact and capable of handling heavy traffic if properly organized. By late August 1944, the weapon that could restore operational momentum was not a tank or a bomber. It was a truck in quantity, properly organized and continuously flowing. The distance problem revealed itself through simple geometry applied to operational logistics. On August 18th, a 1st Army quartermaster officer ran a ruler from Cherbourg to 3rd Army headquarters, then stopped his pencil at a distance that exceeded planned lift capacity by over 100 miles. The gap between available port facilities and advancing forces was growing daily as Patton's columns raced eastward. German intelligence staff calculated that Allied tempo must inevitably stall at the rail gap. Their assessment appeared mathematically sound. Truck transport could not sustain the tonnage requirements of multiple armies over distances exceeding 200 miles. Normal supply doctrine called for truck delivery within 50 to 70 miles of railheads, with rail carrying the burden of long-distance haul. Without functioning rail lines, the entire supply system should collapse under its own distance limitations. Allied staff officers reached different conclusions based on different assumptions. Rail bridges were down, certainly, but roads remained intact. The US Army possessed more trucks than any military force in history. If those trucks could be organized into continuous flow rather than mixed traffic, if dedicated routes prevented congestion, if cargo loading and unloading occurred with assembly line efficiency, then perhaps road transport could substitute for rail during the critical weeks before engineering units restored damaged infrastructure. Port offload rates at Cherbourg demonstrated both possibility and limitation. Liberty ships and other cargo vessels arrived with fuel in 55-gallon drums, ammunition in various calibers, rations, spare parts, and every other supply category necessary to sustain armies in combat. Stevedore battalions unloaded these vessels efficiently, but moving cargo from dockside warehouses to forward depots created bottlenecks. Jerrycan handling illustrated the problem's complexity. The 5-gallon fuel containers, an ingenious German design copied and improved by Allied forces, allowed flexible fuel distribution but created enormous handling requirements. Loading 300,000 litres of gasoline meant moving 15,000 jerrycans by hand, truck, and whatever other methods worked. Handling losses and evaporation consumed several % of total capacity. The physical labour involved in moving millions of jerrycans forward, then returning them empty for refilling, absorbed enormous manpower. Road congestion from bidirectional movement presented perhaps the greatest challenge. Normal military traffic moved in both directions: supply convoys forward, empty vehicles returning, administrative traffic, medical evacuation, prisoner transport, and countless other necessary movements. Every vehicle travelling the wrong direction on a priority supply route consumed road capacity without contributing to forward tonnage delivery. Movement tables compiled by transportation staff showed truck turnaround times exceeding 48 hours on mixed traffic routes. A convoy leaving Cherbourg required 16 hours to reach forward areas under good conditions, longer in darkness or weather. Unloading consumed additional hours. The return trip required another 16 hours. Add maintenance, driver rest, and inevitable delays, and each truck completed perhaps 3 round trips weekly. Increasing truck numbers without controlling traffic flow simply added more vehicles to existing congestion, reducing everyone's efficiency. The problem was choreography, not horsepower. Solve traffic control and cargo handling efficiency, and the campaign's supply crisis could be overcome. Leave traffic uncontrolled, and defeat became mathematically inevitable, regardless of tactical brilliance or operational daring. On August 25, 1944, military police crews bolted round red ball signs to posts along selected routes from Normandy through Chartres toward the Seine corridor. These distinctive markers, a red circle on white background, designated priority supply routes where normal traffic rules no longer applied. A transportation corps route map showed one-way loops. Supply convoys travelled forward on designated roads, while empty trucks returned via parallel routes, never mixing traffic directions. The Red Ball Express had officially begun operations, though the name emerged informally from the railroad practice of marking priority freight trains with red balls. The comparison proved apt. These routes would function like railroad tracks, carrying continuous traffic at controlled intervals, with no interruptions except mechanical breakdown. The contrast with normal highway operations appeared immediately. French roads had served mixed civilian and military traffic under minimal control. Priority cargo moved when space allowed, often waiting behind lower priority vehicles. Convoys broke formation when individual drivers chose different speeds. Traffic moving both directions competed for limited road width, forcing vehicles to slow, stop, or pull aside at frequent intervals. Red Ball routes eliminated these inefficiencies through military discipline. One-way traffic meant convoys never encountered opposing vehicles. Continuous flow doctrine required trucks to maintain prescribed speeds and intervals, regardless of driver preference. Headlights remained on at night despite blackout concerns because maintaining convoy integrity and preventing accidents took priority over concealment from an enemy air force that barely existed. No stopping was permitted except for mechanical breakdown, and recovery vehicles staged along routes ensured disabled trucks could be cleared quickly. Refuel points appeared every 40 to 50 miles, positioned where convoys could pull off the main route, receive fuel from pre-positioned stocks, and rejoin traffic flow without creating congestion. These points operated continuously, staffed by quartermaster petroleum officers who calculated precise fuel requirements and maintained supply sufficient for predictable traffic volumes. First Army and Communications Zone orders specified exact operating procedures. Transportation Corps battalion commanders received authority over their assigned route sections with instructions to maintain flow regardless of local obstacles. Military police established checkpoints at key intersections, directing traffic and preventing unauthorized entry onto priority routes. Corps of Engineers detachments positioned equipment for rapid repair of pavement damage or bridge problems. Initial daily lift approximated 3,600 tons during the last week of August, dominated by petroleum products, gasoline, diesel, and lubricants. This tonnage, while substantial, barely met minimum requirements for advancing armies. But the organized flow represented dramatic improvement over previous methods. Trucks that previously required 48 hours for turnaround now completed cycles in 30 hours. Throughput could be calculated, predicted, and incrementally improved through systematic analysis of bottlenecks. Controlled flow converted the road network into a moving pipeline. German staff officers who had timed an American operational pause lasting weeks watched instead as supply deliveries maintained offensive tempo. The road itself had become a conveyor belt, operating at industrial cadence. The cargo moving along Red Ball routes reflected both operational priorities and handling realities. Load lists documented at depot checkpoints showed 55-gallon drums of aviation fuel, small arms ammunition by the pallet, 105mm and 155mm artillery shells, sea rations, tires, replacement engines, and countless other items necessary to sustain armies in combat. Expectation suggested that mixed cargo would degrade delivery speed and complicate handling at forward depots. The solution implemented by quartermaster and ordnance staffs involved strict load discipline, with priority to petroleum products and ammunition. Trucks carrying these categories received expedited handling at both ends of their routes. Less urgent cargo travelled on separate convoys scheduled around critical deliveries. The GMC CCKW 2.5-ton truck formed the backbone of Red Ball operations. Rated for loads between 2.5 and 3 tons, the vehicle could handle slightly higher weights on good roads without excessive mechanical stress. Each truck required careful loading to maintain proper weight distribution and prevent cargo shifts during the violent maneuvering sometimes necessary on damaged roads. 10-ton tractors pulled trailer trains for bulk fuel delivery, each combination carrying thousands of gallons in specialized tanks. These vehicles required different handling than standard trucks, wider turning radii, longer braking distances, and more careful route selection to avoid bridges or road surfaces unable to support their weight. Jerrycan backhaul represented both solution and problem. Empty fuel containers weighed little but consumed cargo space during return trips. Yet leaving them at forward depots meant those containers could not be refilled for the next delivery cycle. Transportation planners calculated that trucks should return with empty jerrycans rather than running completely empty, accepting reduced efficiency in return for system sustainability. Truck counts in Red Ball service exceeded 6,000 vehicles by mid-September, operated by approximately 23,000 personnel. Roughly 75% of transportation company drivers were African American soldiers, reflecting both the Army's segregation policies and the deliberate assignment of these units to critical logistics missions. These men drove continuously, often for stretches exceeding 12 hours, navigating damaged roads through French countryside while maintaining convoy discipline and fighting exhaustion. Standard loads increased turnaround speed by reducing decision-making at loading points. Cargo handlers knew exactly what each vehicle type could carry and loaded accordingly without waiting for instructions. This systematization reduced loading time from hours to minutes per vehicle, a critical improvement when hundreds of trucks needed loading daily. Reduced breakdowns followed from load discipline. Overloaded trucks suffered mechanical failures at rates far exceeding properly loaded vehicles. Maintaining loads within designed parameters meant engines, transmissions, suspensions, and tires lasted longer between repairs. The seemingly minor decision to enforce load limits protected the entire system's operational tempo. By mid-September, throughput approached 12,500 tons daily, despite steadily lengthening hauls as forward depots moved deeper into France. This increasing efficiency reflected systematic improvements across every aspect of operations: better traffic control, refined loading procedures, improved maintenance, and accumulated experience among drivers and support personnel. The mathematics remained brutal but had shifted from impossible to merely difficult. Every 1,000 tons delivered forward meant another day's combat operations for advancing divisions. Every improvement in delivery efficiency translated directly into operational momentum that German forces could not match or counter. Traffic control along Red Ball routes required military discipline, applied with unwavering consistency to thousands of individual drivers, most of whom had never experienced such regimented operations. The challenge extended beyond mere rule enforcement to creating sustained operational rhythm, despite weather, mechanical failures, driver fatigue, and countless other variables that naturally degraded system performance. September 1944 found military police posts established along the Chartres-Soissons axis and other major corridors, each manned by MPs whose responsibilities exceeded normal law enforcement. At key intersections, white-gloved MPs stepped into traffic flow, holding batons to direct convoys past at precise 2-minute intervals. The timing mattered critically. Too close and vehicles risked collision. Too distant and road capacity went unutilized. The contrast with unregulated French road networks proved stark. Normal traffic moved at variable speeds determined by individual driver decisions, road conditions, and random interactions with other vehicles. Convoys bunched together when led vehicles slowed, then stretched out when speeds increased. This accordion effect consumed road capacity inefficiently and created unpredictable arrival times at destinations. Red Ball doctrine enforced spacing, speed, and no-pass rules that eliminated accordion effects. Convoys maintained prescribed intervals, regardless of conditions. Individual drivers could not pass slower vehicles ahead. The entire convoy moved at the pace of the slowest truck until that vehicle could be removed from the route. This discipline felt oppressive to men accustomed to individual decision-making, but proved essential to maintaining system-wide efficiency. Military Police Group headquarters coordinated checkpoint operations through command posts, equipped with field telephones and radio sets. These hubs received reports from multiple checkpoints, compiled traffic flow data, and identified bottlenecks, requiring engineer attention or route adjustment. The communications network allowed rapid response to accidents, breakdowns, or road damage that threatened to disrupt continuous flow. Corps of Engineers repair detachments positioned along routes maintained bypass construction around damaged sections, installed Bailey bridges when necessary, and performed emergency road repairs. Their presence allowed rapid restoration of damaged routes without requiring traffic to halt while engineering work proceeded. Vehicles detoured around construction, continued operations, and returned to primary routes once repairs completed. Wrecker and tire points addressed the mechanical failures that inevitably affected vehicles driven continuously under heavy loads. Recovery vehicles could remove disabled trucks from traffic lanes within minutes, towing them to shoulder areas where mechanics performed repairs without blocking the route. Tire failure proved so common that dedicated tire points stocked hundreds of replacements and operated continuously replacing damaged tires, tubes, and wheels. Radio nets operated at control posts rather than in individual truck cabs. This centralized communication architecture meant route commanders could coordinate traffic flow, vector recovery vehicles to breakdown locations, and warn checkpoints of delays without requiring every driver to operate communications equipment. The system worked because roads themselves functioned as information channels. Traffic either flowed or stopped, and control posts could observe and respond accordingly. Peak traffic nodes handled hundreds of vehicles per hour without gridlock through precise timing and ruthless enforcement. MPs who allowed cross-traffic to enter priority routes faced immediate relief from duty. Drivers who stopped unnecessarily received written reprimands. The harsh discipline proved necessary because one traffic jam could drop daily lift by thousands of tons, a reduction that meant attacking divisions would run short of ammunition or fuel at critical moments. A traffic plan printed on a single sheet of paper moved more combat power than a division of tanks without fuel. The roads connecting Normandy ports to advancing armies carried more strategic significance than any tactical objective. Control those roads, and victory became achievable. Lose control, and defeat was inevitable regardless of other factors. The trucks themselves required constant maintenance to sustain operational tempo that exceeded peacetime standards by enormous margins. Drivers slept under tarps beside their vehicles, while ordnance contact teams swapped differentials on road shoulders, changed transmissions without proper lifting equipment, and performed whatever repairs kept trucks moving. Assumptions about mechanical attrition suggested that breakdown rates should climb steadily as vehicles accumulated miles under harsh conditions. Reality proved more nuanced. Contact maintenance and systematic cannibalization kept availability rates higher than pessimistic projections predicted, though never reaching levels that allowed relaxation of maintenance discipline. Quartermaster truck companies operated under command structures that placed enormous responsibility on NCOs, many of whom had received minimal training before deployment. African-American sergeants led night convoys through blacked-out French countryside, navigating by dead reckoning and occasional map checks, maintaining unit cohesion despite weather and fatigue, and delivering their cargo regardless of obstacles. Their leadership under impossible conditions rarely received recognition, but proved essential to system sustainability. Ordnance contact teams moved along routes continuously, carrying common spare parts and tools necessary for roadside repairs. These mechanics developed extraordinary improvisation skills, adapting parts designed for different applications, using field-expedient methods that would horrify factory engineers, and returning broken trucks to service through determination and ingenuity. Tire wear rates exceeded every prediction. The combination of heavy loads, damaged roads, high speeds, and continuous operations destroyed tires at rates approaching 1 per 1,000 miles. Tire points along routes stocked mountains of replacements and employed crews who could swap all 6 tires on a CCKW in under 30 minutes without proper equipment, just jacks, pry bars, and determination. Oil change intervals recommended every 3,000 miles under normal conditions became flexible guidelines under Red Ball operations. Trucks received oil changes when opportunity allowed rather than at prescribed intervals, trusting that high-quality lubricants could survive modest interval extensions without catastrophic failure. This calculated risk accepted modest engine wear in return for maximum operational availability. Average service life before major mechanical work required approximated 3,000 miles, though individual trucks varied enormously based on driver skill, load discipline, and chance. Vehicles requiring major repairs were pulled from service, transported to rear area depots, and either repaired or cannibalized to provide parts for other trucks. The constant attrition meant truck companies maintained strength through continuous replacement rather than keeping original equipment operational indefinitely. Wrecker and recovery cycles operated continuously. Disabled vehicles appeared regularly enough that recovery procedures became routine. Mechanics learned which components failed most commonly and pre-positioned replacement parts accordingly. Drivers learned to recognize warning signs of impending failures and nursed damaged trucks to checkpoint locations where repairs could occur safely off the main route. Unit histories documented fatigue accidents, but also noted surprisingly low net downtime due to forward repair capabilities. The transportation system absorbed constant minor failures without catastrophic degradation because maintenance doctrine emphasized returning vehicles to service quickly rather than performing perfect repairs. Trucks operated with mismatched tires, improvised repairs, and accumulated damage that would be addressed during future overhauls if the vehicles survived that long. Human endurance proved as critical as mechanical reliability. Drivers operated for 12 to 16 hours daily, then slept in rough field conditions before repeating the cycle. Medical officers reported climbing rates of fatigue-related illness, but few drivers accepted medical evacuation when their absence meant another soldier would have to cover their route. The quiet statistic that determined campaign success appeared in daily reports as availability rate. This percentage, trucks operational divided by trucks assigned, remained the critical metric. Not horsepower, not cargo capacity, not maximum speed, but simply the proportion of assigned vehicles that could roll when called upon. That figure, sustained above 70% through September and October, determined how far Patton could advance that week. While American trucks rolled continuously along French roads, German logistics collapsed under compounding pressures. The contrast between systems illustrated how operational level advantages translated into strategic outcomes, regardless of tactical excellence or battlefield heroism. August through October 1944 found German Army Groups B and G rear areas struggling with supply crisis that approached catastrophe. Depot officers signed ration slips against dwindling fuel ledgers, calculating how many more days their stocks would sustain combat operations. Trains arrived late when they arrived at all, their schedules disrupted by Allied air attacks and systematic infrastructure destruction. U.S. road redundancy meant that damaging one route simply shifted traffic to parallel roads. German reliance on rail transport meant that destroying key bridges or marshalling yards severed entire supply networks. Allied fighter bombers roamed freely over France, attacking locomotives, rail cars, bridges, and anything else moving by day. German logistics operations occurred primarily at night, under conditions that reduced efficiency even when attacks did not materialize. Panzer, Lehr, and other armored divisions submitted reports documenting fuel shortages that prevented operational maneuver. OKW fuel summaries compiled at Wehrmacht High Command showed steadily declining allocations as Romanian oil production. Germany's primary petroleum source ended with the August loss of Ploiești fields to Soviet forces. Luftwaffe allocations received priority, but even Air Force units operated under increasingly severe restrictions. German forces experimented with fuel substitution, using wood gas generators and synthetic fuels of limited octane rating. These desperate measures sustained minimal mobility, but could not support the sustained high-tempo operations necessary for mobile defense against advancing Allied armies. Armored units conserved fuel by remaining stationary, moving only when absolutely necessary to counter immediate tactical threats. Horse-drawn transport reappeared in German logistics networks during autumn 1944, a regression that symbolized the Reich's collapsing industrial capacity. Horses required fodder rather than gasoline, moved slowly, and carried limited loads, but they could move when fuel allocations ran out. The sight of Wehrmacht divisions dependent on animal transport illustrated how completely Germany's mechanized advantages had evaporated. Battalion returns from German units listed vehicles as combat-capable immobilized for lack of fuel. This devastating assessment acknowledged that tactical formations possessed equipment and personnel to fight but could not reach battlefields or reposition to meet threats. Immobile armored divisions surrendered their fundamental advantage mobility and became fixed defensive positions vulnerable to Allied firepower superiority. German maneuver capability shrank to village defense, while U.S. maneuver capacity expanded with every convoy arrival. The tactical equation shifted decisively as American divisions could concentrate forces against any threatened sector, while German divisions remained locked in positions determined by fuel availability rather than operational necessity. Strategy gave way to arithmetic tons per day delivered versus tons per day available. German generals recognized this reality even as propaganda ministry statements claimed imminent victory. In private assessments and post-war interrogations, Wehrmacht officers acknowledged that logistics defeat preceded tactical collapse. Germany's armies remained capable of local counterattacks and stubborn defense, but could not sustain operational-level maneuver that might have disrupted Allied advances. The contrast became clearest when measuring freedom of action. American commanders chose where to attack based on operational objectives, confident that logistics would support their decisions. German commanders chose where to defend based on fuel availability, accepting that superior positions might be abandoned simply because troops could not reach them. By October, the gap had become unbridgeable. Allied supply capacity continued improving as engineer units restored rail lines and forward depots moved closer to combat zones. German supply capacity continued declining as Allied bombing intensified, fuel stocks depleted, and infrastructure damage accumulated faster than repairs could address. The Western European campaign's outcome was becoming determined not by who fought hardest, but by who could keep moving longest. That question, already decided by September, would only become more apparent as autumn progressed. The operational pursuit toward the Seine and beyond during September 1st through 15th, 1944, demonstrated how sustained logistics enabled continuous offensive pressure that German forces could not counter effectively. Bridging columns laid treadway spans across the Seine while convoys idled on schedule, drums stacked to horizons, waiting for forward movement authorization. Third Army crossed the Seine on August 25th, weeks ahead of planning schedules, and continued eastward toward the Moselle River. Each river crossing required engineer support to establish bridges capable of handling heavy traffic. Each delay waiting for bridging operations consumed time, during which German forces could reorganize defenses. Yet the delays remained brief, because engineer units operated with same industrial efficiency as truck convoys standardized equipment, rehearsed procedures, and practiced coordination. Once across the Seine, Patton's columns advanced at rates exceeding German withdrawal speeds. Wehrmacht divisions attempting to establish defensive positions found themselves outflanked before positions could be prepared. American reconnaissance elements reached objectives before German staffs issued orders to defend them. This tempo reflected not merely tactical aggressiveness but logistical sustainability. The attacking divisions possessed fuel, ammunition, and supplies sufficient to maintain pursuit without operational pauses. German corps proved unable to reorganize coherent defenses because the time necessary for reorganization exceeded the time American advances allowed. A division withdrawing from one position toward another prepared defensive line would find that second line already compromised by American penetrations before the division completed its withdrawal. This cascading collapse resulted directly from mobility differentials created by logistics superiority. U.S. supply lines stretched dangerously, but held due to truck convoy operations that adapted continuously to expanding distances. Red Ball Express routes extended eastward as armies advanced, with new checkpoints established and forward depots relocated to maintain delivery efficiency. The system remained fragile. Any major disruption would have forced operational pauses, but no such disruption materialized because German forces lacked capability to interdict American logistics networks. The turning point had arrived, though its significance would only become clear in retrospect. The German army had lost freedom of maneuver that defines operational success. German divisions could fight defensively with skill and determination, but could not maneuver offensively to regain initiative or disrupt American operations. The initiative had transferred permanently from defender to attacker, from Wehrmacht to U.S. Army, from Germany to the Allied coalition. September operations in Lorraine through October demonstrated that fuel delivery rates determined offensive sustainment more directly than any tactical factor. Tank commanders requested fuel status updates before planning movements. Convoys arriving hours before halt orders allowed operations to continue another day or drive another 20 miles. The margin between success and stalling measured in thousands of gallons delivered per day, a metric entirely dependent on truck convoy performance. German counterattacks during this period failed consistently due to delayed movement resulting from fuel shortages. Wehrmacht doctrine called for rapid concentration against penetrations, but rapid concentration required fuel for movement. Divisions ordered to counterattack positions that American forces had seized hours earlier arrived late or not at all because they lacked petroleum products necessary for timely maneuver. Red Ball Express throughput peaked near 12,500 tons daily during mid-September, an achievement that reflected systematic improvements across every operational component. Drivers knew their routes intimately. MPs had refined traffic control to minimize delays. Maintenance procedures had adapted to repair common failures efficiently. Loading and unloading operations occurred with assembly line precision. The entire system had evolved from desperate improvisation to functioning industrial process. U.S. divisions sustained offensive momentum through October, despite increasing resistance from German forces attempting to defend the Reich's western border. This sustained pressure prevented German forces from establishing stable defensive lines or accumulating reserves for counteroffensive operations. Every day of continued Allied advance shortened the war's duration and reduced total casualties by preventing protracted campaigns against fortified positions. Germany's operational flexibility had been lost, forced into static defensive warfare that favored the side with material superiority. Wehrmacht tactical excellence remained formidable, but tactics could not overcome operational-level disadvantages created by logistics collapse. The principle had been proven definitively. Momentum once lost cannot be regained when the losing side lacks logistics capacity to support offensive operations. Germany would fight for 8 more months, but the outcome had been determined by petroleum products delivered per day and the truck convoys that sustained that delivery. By autumn 1944, the strategic significance of logistics as a war-winning weapon had become undeniable, even to observers who initially dismissed supply considerations as mundane compared to battlefield heroics. German staff reports documented the transformation with brutal honesty that would later provide post-war historians with primary source evidence of how the campaign was actually decided. Wehrmacht after-action reports listed armored formations as combat-capable, limited by fuel. This assessment appeared repeatedly in Corps and Army group summaries throughout September and October. The phrase acknowledged tactical readiness, crews trained, equipment functional, ammunition adequate, but operational impotence due to petroleum shortages. Divisions marked combat-capable could not reach battlefields where their presence would have influenced outcomes. U.S. Army Service Forces evaluation documents confirmed from the opposite perspective that supply tempo decided operations. First Army quartermaster summaries tracked daily tonnage delivered against consumption rates, noting that periods of rapid advance correlated precisely with periods of maximum supply throughput. When truck convoys delivered above-average tonnage, offensive operations accelerated. When deliveries declined due to weather or mechanical difficulties, operational tempo slowed proportionally. The correlation proved so consistent that staff officers could predict advance rates based on logistics reports rather than combat assessments. If fuel arrived at specified rates, then attacking divisions would drive specific distances. If ammunition deliveries met planned levels, then artillery support would sustain required intensity. Logistics metrics became operational planning factors with predictive value exceeding tactical intelligence. German generals captured during the campaign's final months acknowledged logistics defeat in interrogations conducted by Allied intelligence officers. General der Panzertruppen Fritz Bayerlein, commanding Panzer Lehr Division, stated bluntly that American logistics determined the campaign's outcome more decisively than American tactics or German defensive efforts. Other senior officers echoed similar assessments, noting that Wehrmacht tactical excellence proved insufficient against enemy forces that never ran short of fuel or ammunition. Post-war U.S. Army evaluations identified the Red Ball Express specifically as the operational innovation that prevented logistics crisis from forcing a campaign pause during autumn 1944. Without systematic truck convoy operations, First and Third Armies would have stalled at the Seine while engineers restored rail lines, a delay measuring weeks or months, during which German forces could have reorganized defenses and potentially created conditions requiring a second major offensive rather than sustained pursuit. The strategic turning point occurred not during any particular battle but across accumulated days, when American divisions maintained offensive pressure that German divisions could not counter effectively. That sustained pressure resulted directly from logistics systems that delivered necessary supplies despite expanding distances and damaged infrastructure. The war would continue for 8 more months, but the outcome had been set during those critical weeks when trucks rolled continuously along French roads. This marked the campaign's fundamental transformation. Germany entered autumn 1944 unable to regain operational initiative regardless of tactical successes at local level. The Reich's armies could defend stubbornly, inflict casualties, and delay Allied advances, but could not alter the strategic trajectory toward German defeat. That trajectory had been determined by tonnage delivered daily, routes controlled systematically, and the industrial capacity that produced trucks faster than combat could destroy them. By November 1944, the operational necessity that created the Red Ball Express had diminished, as engineering units restored rail infrastructure and forward depots moved closer to combat zones. The transition from emergency truck convoys to normal rail-dominant supply occurred gradually, without the dramatic collapse that pessimists had predicted. November 16th through 30th marked the official stand-down period as rail lines reopened throughout liberated France. Engineers had rebuilt bridges across the Seine, repaired marshalling yards near Paris, and restored track between Atlantic ports and forward areas. The rail network remained damaged compared to pre-war capacity, but functioned adequately to handle majority cargo movement without requiring continuous truck convoy operations. The last Red Ball convoys completed their runs during mid-November, delivering final loads before being reassigned to general transportation duties. Military police crews removed the distinctive Red Ball signs from route markers, returning roads to normal traffic patterns. The priority corridors that had carried the campaign's logistics burden for 3 critical months reverted to standard military highways subject to normal traffic control. Communications zone reports documented the transition, with statistical summaries showing declining truck tonnage offset by increasing rail tonnage. The crossover point occurred in early November, when rail deliveries exceeded truck deliveries for the first time since the Normandy breakout. Transportation Corps after-action reviews noted that the transition proceeded smoothly without operational disruptions, validating the planning that had treated truck convoys as temporary measures rather than permanent solutions. Fears of logistics collapse during the transition proved unfounded. Allied supply systems possessed sufficient redundancy that temporary reductions in either truck or rail capacity could be absorbed through adjustments in the other mode. The careful planning that enabled Red Ball operations also enabled their graceful conclusion when circumstances changed. Truck units previously dedicated to Red Ball routes received reassignment to general haul missions and winterization preparations. The approaching cold weather required vehicle modifications, supply stockpiling, and training for operations under conditions dramatically different from summer and autumn. Units that had driven continuously since August received maintenance stand-downs, during which vehicles underwent depot-level repairs, addressing accumulated damage from months of intensive operations. Red Ball Express totals, compiled from transportation logs and quartermaster records, documented the system's extraordinary achievement. Over 412,000 tons of petroleum products, ammunition, rations, and spare parts had been delivered during the 81-day operation period. Truck availability rates, despite constant operations under harsh conditions, averaged above 70% throughout the period. Accident statistics, while concerning, remained within acceptable parameters, given the operational tempo and conditions involved. The emergency corridor had fulfilled its purpose, carrying the front across France before winter stalled operations. Without those deliveries, American armies would have halted weeks earlier, allowing German forces time to establish prepared defenses along natural barriers like the Moselle and Rhine rivers. The campaign's rapid pace, made possible by sustained logistics, prevented such German reorganization and positioned Allied forces for eventual victory. German post-war officers would concede what the ledgers had already shown. Wehrmacht tactical skill could not overcome operational level advantages created by logistics superiority. The American transportation system, combining trucks and rails in complementary fashion, had sustained offensive operations at tempo that German forces could neither match nor effectively counter. The evidence appeared in fuel consumption records, ammunition expenditure statistics, and casualty rates, showing that American divisions maintained offensive capability throughout periods when German divisions remained immobilized or undersupplied. The final accounting proved brutal in its clarity. U.S. forces had sustained operations across distances and at tempos that exceeded every pre-war planning assumption. German forces had failed to prevent this because they lacked comparable logistics capacity. The campaign demonstrated that modern warfare outcomes emerged from industrial capacity, systematically applied, rather than from tactical excellence alone. The strategic lessons learned from Red Ball Express operations would shape military logistics doctrine for decades, influencing planning for future conflicts and establishing principles that remained relevant into the 21st century. U.S. Army evaluations during 1945 through 1950 analyzed the campaign systematically, extracting lessons for institutional knowledge. Staff College lectures during the immediate post-war period featured slide presentations titled Throughput versus Outcome, ETO 1944, that examined the correlation between supply delivery rates and operational success. These presentations documented how logistics capacity had enabled sustained offensive operations, while logistics limitations had prevented effective German response. The statistical evidence proved overwhelming materiel superiority had translated directly into operational advantage. German general officer interrogations, conducted during 1945 and 46, provided enemy perspective on the campaign's determining factors. When asked why Wehrmacht forces could not prevent Allied advances despite local tactical successes, captured generals consistently cited fuel and transport shortfalls under air interdiction. Field Marshal Gerd von Rundstedt stated that American logistics determined the campaign's pace more decisively than any tactical consideration. Other senior officers acknowledged that Wehrmacht excellence in tactical operations could not overcome fundamental disadvantages in supply capacity. Early NATO doctrine studies examined the Red Ball Express as case study in how alliance logistics could support sustained operations. The principles demonstrated during autumn 1944 standardized equipment, interchangeable parts, systematic traffic control, and complementary use of road and rail transport became foundational concepts for NATO logistics planning. The alliance's ability to sustain forces in potential conflict with Warsaw Pact nations depended partly on lessons learned from American experience in France. The contrast between materiel quality and tactical finesse versus industrial mobility and replacement depth became central theme in military education. Red Ball Express operations had demonstrated that adequate equipment deployed in quantity often proved superior to optimal equipment deployed in limited numbers. This principle influenced procurement decisions throughout Cold War period, with planners consistently emphasizing availability and sustainability over theoretical performance maximums. Standardization carried into post-war vehicle fleets across NATO militaries. The recognition that interchangeable parts enabled rapid field maintenance and simplified logistics led to international standardization agreements covering everything from ammunition calibers to fuel types to vehicle components. These agreements traced directly to lessons learned when American standardized truck fleets sustained operations while German mixed fleets collapsed. Roads and rails were planned as complementary transport modes rather than competitive alternatives in post-war logistics doctrine. The recognition that each mode possessed advantages under different circumstances led to integrated transportation planning that maximized total system capacity rather than prioritizing either road or rail exclusively. This integration reflected lessons from France, where trucks sustained operations during rail restoration period, then reverted to supplementary roles once rail capacity returned. Transportation Corps training programs incorporated Red Ball Express case studies, showing how systematic operations management enabled sustained logistics under adverse conditions. Officer candidates studied traffic control procedures, maintenance practices, and organizational structures that had enabled continuous truck operations across distances that traditional doctrine considered impossible for sustained road transport. The documented fact that emerged most clearly from all analysis was simple but profound. Controlling flow, not merely accumulating stock, determines operational success. Millions of tons of supplies sitting in depots hundreds of miles from combat zones provided no operational advantage. Thousands of tons delivered daily to forward areas enabled sustained offensive operations that defeated enemies regardless of their tactical excellence. The difference between having supplies and delivering supplies had proven decisive. German assessments reinforced this conclusion from the losing side's perspective. Wehrmacht had possessed tactical excellence, defensive skill, and individual soldier quality that equaled or exceeded Allied forces in many respects. But German logistics could not sustain operations under conditions of Allied air supremacy, infrastructure destruction, and fuel shortages. Excellence without sustainability proved insufficient. The final assessment, repeated across countless military studies and historical analyses, remained unambiguous. The Western European campaign was decided not by who struck hardest, but by who kept moving longest. That endurance was measured in tons delivered per day, mile after mile, through systematic operations that converted industrial capacity into battlefield advantage. The Red Ball Express, operating for 81 critical days during autumn 1944, had demonstrated this principle definitively. The legacy extended beyond military applications into civilian logistics systems. Commercial trucking companies studied Red Ball operations to improve their efficiency. Traffic engineers examined the highway control methods that enabled sustained flow. Industrial efficiency experts analyzed how standardization and systematic procedures created measurable performance improvements. The wartime emergency system provided lessons applicable to peacetime logistics challenges. Today, military logistics planners continue referencing Red Ball Express as historical example of how systematic operations overcome seemingly insurmountable challenges. The campaign demonstrates that modern warfare outcomes emerge from sustained logistics capacity more certainly than from tactical brilliance. This lesson, learned through desperate necessity during summer and autumn 1944, remains fundamental to understanding how industrial democracies convert economic advantages into military victories. The trucks have long since been scrapped, the roads returned to civilian use, and the men who drove those convoys mostly passed. But the principle they demonstrated endures. Victory in modern warfare flows to the side that can sustain operations longest. The Red Ball Express proved that industrial capacity, when systematically organized and persistently applied, determines strategic outcomes, regardless of tactical situations. August 28, 1944, began with empty fuel tanks threatening to halt Third Army's advance. It ended with priority orders establishing continuous truck convoys that would sustain offensive operations for the next 3 months. That transformation from logistics crisis to logistics solution changed the campaign's trajectory and shortened the war in Europe. The German war machine did not break from tactical defeat or operational encirclement. It broke because American trucks rolled continuously, delivering petroleum products faster than German forces could interdict or counter. That delivery rate, sustained across impossible distances under harsh conditions, determined the campaign's outcome more decisively than any battle. The Western War was not decided by who struck hardest, but by who kept moving longest measured in tons per day, mile after mile, through standardized trucks driven by determined men along controlled routes that became weapons themselves. The Red Ball Express demonstrated this principle so clearly that military historians still study its operations 8 decades later, seeking to understand how logistics became the decisive weapon that broke the German war machine. What is your perspective on this part of history? Share your thoughts in the places. Comments, because every memory and reflection helps keep the past alive.